In this module, we are going to prove the famous intermediate value theorem, which you might recall was the way we started our course. Before that, let me just state a proposition which is quite easy to prove now that we have extensively studied various equivalent ways of defining connectedness. Let S subset of R be connected and F from S to R be continuous. Then F of S is connected. The image of a connected set under a continuous mapping is connected. To visualize this, you can think of a connected set as a set that is there in one piece, and a continuous mapping cannot rip this into two pieces. Proof. Suppose F of S, or let me not prove by contradiction, let me give a direct proof. Let G from F of S to 0, 1 be a continuous function. Consider G composed with F from S to 0, 1. Okay? Because S is connected, this function must be constant. Therefore, the function G must also be constant. Hence F of S is connected as required. Now, how does this help us in our quest to prove the intermediate value theorem? In fact, this proposition makes quick work out of the intermediate value theorem. You can immediately prove the intermediate value theorem. Intermediate value theorem. Let F from I to R, or rather let me just state it like this. Let F from A to R be continuous. Okay? Let A1 comma A2 be in A such that closed interval A1 A2 is a subset of A. Okay? Then for all C such that C lies in F of A1 F of A2, or C that lies in F of A2 F of A1, depending on whether F of A1 is less than F of A2 or F of A2 is less than F of A1. Okay? Depending on whether this, you choose C in either the closed interval F of A1 F of A2 or C in F of A2 F of A1. If F of A2 happens to be equal to F of A1, then this result is entirely trivial. I'm not even going to take that case. I'm going to assume F of A1 is not equal to F of A2. If F of A1 equal to F of A2, this result is trivial. So depending on whether F of A1 is less than F of A2 or F of A2 is less than F of A1, choose C in this. Then then for some b in closed interval a1 a2, f of a1 equal to b. Sorry, f of b equal to c. Okay, proof. Now just assume that f of a1 is less than f of a2. The other case is perfectly the same. Okay, then as closed interval a1 a2 is connected, f of a1 a2 is also connected. That's just the previous proposition. Okay, but f of a1 comma f of a2 is an element, or both elements of f of a1 a2. Therefore closed interval f of a1 comma f of a2 is a subset of f of a1 a2. This is just from previous module. Please go back, and there's a big theorem in the previous module that immediately gives this. Okay, so this essentially proves what we need. That's it. Proves what we need immediately. Okay, so the intermediate value theorem has been reduced to two facts about topology. The first fact is the characterization of connected sets in R. The second fact is that the image of a connected set under a continuous mapping is connected. You can prove this intermediate value theorem without using topology at all, and that is directly using the nested intervals property and completeness. You can't just use nested intervals property. You need to use the Archimedean property also. That's there in the exercises, how to prove it directly. But you will accept that this proof is not only more elegant, but it gets to the heart of the matter. And to precisely see how clarifying this particular proof is, please solve that exercise. This is a course on real analysis, and you have just watched a module on the intermediate value theorem.